Okay, Richard and Jason and all good friend here. I'm so proud to be here. And actually, I study. I think 20 years ago, Austin mentioned to me. He said, "What is the reason about the ginseng that has been used for in the past 2,000 years in not only China but also the Oriental society, and what is the reason behind?" And then that is how we get started. Okay, and before we start that, we just found that the component in ginseng is sort of changing over time. And if you put the ginseng in one soil compared to another soil, you found that the composition inside the ginseng is going to be varied.
Okay.
So that means if you want to have the ginseng to be a reliable nutraceutical, then it's very difficult. And also the season is going to change, right? So let's say you have the soil, right, in the summer, right? You cultivate the ginseng in the same soil during the summer, and then several seasons later, you found that although it's the same soil and the same species, the composition also changed.
Is that just the natural variability of plants?
No, the plant is the same.
Okay.
But if you cultivate it in the same soil, different you sort of get the product out in different season. The composition also changes.
Other plants did this to the soil?
It's the same.
No, as in if you had done this test with another plant besides ginseng?
Yeah, every is the same for all species. Okay, so that becoming very tricky for you to standardize the product.
Right.
Right. And I would say one of the most important strengths of this product is that is standardized.
To RG1, correct?
Yes. At the beginning, we thought that the composition of the ginseng is probably RB1. There are more than 30 different type of steroid inside the ginseng. 30 different type, right?
Okay. Wow.
So it's very, very difficult to sort of sorting out which component is the most important that has the physiological action, right? So at the beginning, we just sort of using metabolic test and see which one is the one that really give you the physiological action. The most abundant one is the RB1, but we eventually found that it's the RG1.
That has the most effect on
Metabolic effect.
Metabolic, okay.
Right. And therefore, at that time, I give the idea to Austin and to say we should only focus on this composition. Okay, and we didn't publish the data until last year, so it's 20 years ahead, and then we just published last year.
So your lab was sitting on 20 years of data that has never seen the light of day.
Right, because there's a secret for the company.
Right.
So if you have this kind of foundation, then it's very difficult for someone else can sort of
Understood.
replace your position.
Yeah.
Right. So I'm going to talk about the Senactiv for the muscle performance today, and this would also give you the background. How do you position this product?
Awesome.
Okay, next. Okay, the first question for everybody is, if you could control the cell death and the cell regeneration at your will means your brain, okay? Then could we stay young forever and fit, young and fit forever?
Is that a trick question?
So that means if if I can control, you can control yourself. You have the cell that would age, right, and would die, right, and regenerate, right. So if you can control the process and to maintain the younger cell age population in your body, then you should be able to live forever and young forever, in theory, right? Yeah, but one of the reasons you do not witness this is because we do not know how do you keep that, right? And so the exercise and nutrition becoming very important, right? And if you know the knowledge, then you'll be able to maintain your usefulness. So today I'm going to give you the foundation of this.
Interesting. Okay.
And I do not believe you can learn this anywhere else in the world. Okay, next.
We're getting first peek. That's
Yeah.
groundbreaking research, y'all.
Right. And this is this is very important data that just published for the first time in 2009 that demonstrate for human, if you are aged at 50, the exercise will make you younger. Okay, exercise is anti-aging. So this is the study that has been conducted in Scandinavia, and it has 2,205 participants.
So it's a
And
large study group.
It's very large, and you have their age is all above 50. Okay, and then if you look at the cumulative total mortality from age 50 until their age of 85, you can see that which kind of physical activity give you the lowest mortality. Just look at that.
High physical activity, right?
High physical activity.
Did they define high physical? Is it 150 minutes of moderate exercise per week, or?
Yeah, they have the definition. The low physical activity is like the housekeeping job. Okay,
Right.
so that kind of level. And for the high activity is structured. Let's say you are going to the gym and you have higher intensity,
Okay.
right? Okay, so this is giving you the idea that if you, after age 50, then you maintain your physical activity higher, then you can live longer, right? Go to the next one. Okay, in this big cohort, you can also see that some people, they are high physical activity and switch to the low and medium physical activity. Okay, that is the red line. And there are some people, they used to have the low physical activity and switch to the medium and high physical activity. Right, that is the blue line. Okay, when they start to change their behavior, 15 years later, you see the blue line and the red line get crossed. So what does it mean? That means the mortality changed when you change the behavior.
Mm-hmm.
So this is very good evidence to show you that even you are age over 50 years of age, okay, then you increase your physical activity. 15 years later, you're becoming younger, okay? And because I think most of the business, they need to do good for the society, right? So I think this is very good for the NuLiv Science to see that you are the company that is contributing to the society. You are the promoter of exercise in sports, high physical activity, right? Okay, then the question comes. Think about this. If you have a fundamental physics in high school, okay, you know that all physical and chemical process that increase the entropy. The increased entropy means facilitating the breakdown, right? So if you have high physical exercise, high physical activity, compared to low physical activity, which one gives you more entropy?
Hi.
Yeah, of course. Everybody know, right? So it should break down your body, right? But how do you explain the high physical activity make you younger and living longer, right? So that is the question that not too many people answer, but the evidence is getting quite clear after 2009. So this science is very, we just discover, it's the very new knowledge for everybody here.
So can I pause real quick? So increased physical activity leads to higher entropy. Yet at the same time, we've the study shows that increased physical activity also reduces your mortality. So even though you have higher entropy, you also have lower risks of mortality compared to someone that does not exercise.
That's right.
Correct. Okay.
Yeah. Let me just give you another example. You know, we're sitting here, we have the challenge by gravity, right? And if you go to the space station, then you do not have
Right.
the challenge, right? But if you look at the muscle, you know what happened in the muscle?
Yeah, starts degrading.
Yes. You know, atrophy
Atrophy.
is taking place quickly in 2 weeks.
2 weeks? Oh, wow.
Right? So that also gives you the idea that the challenge that make your muscle growth.
The stress of it, yeah.
Yeah.
Interesting. Just
Right.
gravity alone. Yeah.
Yeah. So today I'm going to present the knowledge behind this. And then hopefully it will be easy for everybody here. And I hope hopefully the sales and marketing staff is able to present. Okay? Yeah, go to the next. Okay. First, I would like to mention that the Senactiv is the RG1-based sports senolytic supplement. So do you know what is the senolytic mean?
Anti-aging, correct?
No, it's senolytics means they will kill your senescent cell.
Okay.
Any intervention that kill your senescent cell in human body.
Okay.
That is the what we call senolytic effect. Okay. And just give you the answer that what is Senactiv. Senactiv is the formula that designed to warm up your immune system to eliminate senescent cell. Okay. So in our body, most of the cell they age quickly, and you need to have the mechanism to recognize what is the young and what is the old cell. And then the system need to specifically recognize the old cell and kill them. And therefore your body, the average cell age in your body is going to be young, right? So you need to have this kind of mechanism. Everybody here, we have that mechanism. So if the people say that the human body has the healing power, do we have the healing power?
Yes.
Yes, of course. Yes. And that is immune system. Okay? And if you are able to eliminate the aged cell in your body
Then you can stay
periodically,
young.
theoretically, you can stay young and fit forever. Right? So that is very simple theory. Right? Yeah, and also the Senactiv is standardized by the RG1, which is purified from Parnax noto ginseng. And actually not the only noto ginseng, the ginseng also have the component of RG1. So there are many type of the plant that has the RG1 component. And if you look at the chemical structure, it's like steroid.
Interesting.
Okay. And what is the function of the RG1? It's not fully characterized, but I can give you the most advanced knowledge today, the most updated knowledge today. Okay, and as I just mentioned, the RG1 composition in the plant is actually vary by season, species, and soil. Right. So that is the greatest strength for the NuLiv Science to give the reliable, reproducible
consistency.
Outcome. Yes. So I'm very confident to say that the RG1 can improve the performance for human. Okay. And we just recently found that if you mobilize the immune cell into any tissues, the immune cell is going to recognize the aged senescent cell in that tissues and clear the senescent cell.
In any tissue, so it's no longer just muscle?
Any tissues.
Wow.
Not only muscle. So that means if you want to make your brain younger, you can also do the same. You want to make your skin looks younger, you can also do the same. But if you want to selectively make your muscle younger, you have to direct your blood into the muscle.
Through physical exercise, right?
Yeah, that physical exercise is the best way to do it. So let's say if you do like walking, you only mobilize your very small portion of the muscle. So you have to do high intensity to mobilize the blood into more muscle tissues. So that is the reason.
So would you recommend like, at least zone 4 or even zone 5 cardio phase to actively now your heart rate's like 90% of max, right? So blood's going everywhere to every tissue, right?
Especially muscle. Muscle and the brain.
Okay.
Yeah. Muscle and the brain and the skin. Depending on what type of exercise. If you are aerobic exercise, it also goes to the pulmonary system. But if you just do resistance training, then the blood is more in the muscle instead of pulmonary system. Right? Okay. Next. Last one. Sorry. Last one. Okay. Finally, we do muscle physiology, and we found that for the age between 20 to 25, which is very young, right? So you do not think the young people, they have the senescent cell in their muscle, right? We do not believe.
So you're saying that at 20 years old, our muscles are already starting to age?
Well, when we take out muscle, we are very surprised. We found that you cut the muscle and then you stain for the senescent cell. You found that 40% of the endothelial progenitor cell, which is the vascular stem cell, they are aged.
Wow.
And a young, healthy adult.
Yeah.
Normally, you would think that's 10 years from that. Like 35 is aging. But you're saying that peak is, wow, in 20 to 25.
And then if you look at the literature, then you understand why. Because the vascular stem cell, the vascular endothelial cell has the longevity only 2 weeks. So that means from your body and my body, we have the new birth of the endothelial cell, and 4 days later, they get into the middle age.
So the lining of all of our blood vessels, pretty much the cells only last 2 weeks. Really?
Yes.
So it's just
2 weeks.
So that will explain why it's a large percentage is in senescence, because at any time it's being generated or being regenerated or dying, right?
Exactly.
Okay. Wow.
So, so you need to figure out what is the best way to, if they are 1 week of age, they are already in the middle of their lifespan, right? And several days later they are going to die, right? And if you have the population age shift to older population, then your body function is not going to be good, right?
Is this consistent over time? If you were to take someone endothelial cells from 40 or 60, is it always around that 40% range?
Well, this is for the young people.
Yeah. What about
For
older
the age,
people?
like 21, averaging 21 years old. If you look at the infant embryo, you also see senescent cell because they also metabolize quickly. Okay, because we are multicellular.
Yeah.
Right? And if you look at the older people, we haven't calculated, but this is what we have for the young people like you.
Wow.
Okay, and so that is the reason we start to pay attention on endothelial progenitor cell, and that is why we collaborate with Brandon Harris, and he's the expert in vascular physiology. Okay, next. Okay, so come back to the question I just mentioned. If you are able to kill the senescent cell in your body and then replace with the new one, if you can do that artificially, then will you be able to increase your fitness and longevity? The answer is yes. Okay, and you see this paper is published in 13 years ago. It proved the concept that if you have, you see,
is that published in Nature?
Yes.
Wow.
Yeah.
That study made to Nature. Okay.
Yeah. You see the standing upper. You see right here on the left upper graph. You see that is the SA beta gal, and that is the staining cell staining for senescent cell. Okay. If you trigger the gene that kills the senescent cell, the cell looks like in the bottom, right? You see that? You see the blue is the senescent cell stain, and if you kill them, then it's like that. Okay, so if I'm able to kill the senescent cell in your body, okay, and if you look at their longevity and their fitness, it's all improved. You look at on the right side, that is the improvement over untreated. And you can see that the time of the running and the distance of the running and the work they can perform is all improved. And this is the middle-aged mice. So that proved the concept that if you have the product that is able to do the same thing, then your performance is going up. Longevity is longer.
Wow.
And I'm proud to say that the Senactiv is the only option in the market.
It's the only option in that area where you're currently studying of senescent cells, right? Oh.
Yes.
Wow. And for people that don't know, Nature is maybe top 5 journal in the world. Nature, Cell.
That's prestigious.
Yeah.
Okay, let's go to the next. Okay, then I'm going to give you the foundation. I'm also hoping that will give you the knowledge to maintain yourself young forever. Okay, and I will also give you the reason that why most of the people cannot achieve unlimited lifespan. Okay, yeah. The first foundation is that we need to aware that humans are multicellular. Okay, so that means if you look at the cell marker, you see the cell, they express a lot of protein and gene, and they can get aged, right? And their lifespan is very short. If you just look at the cellular molecular marker, it doesn't really represent how robust you are and how long you can live. It does not really give you the the status, whether you are young or not. So the cellular marker means, to me, means not very limited. Okay, so if you look at a lot of molecular marker, it's not important. You want to look at the fitness and longevity and how young you look, whether your body composition looks nice.
So individual cellular markers are not a great predictor of longevity or health span?
It's not.
Interesting.
Okay, let me just give you a very important remark.
Uh-huh.
If you challenge your body by exercise, and then you take out the tissues, immediately you found the aging marker is all increased. You see the free radical increase, RS is going up, you see inflammation. You see the blood marker is going to the wrong direction, right? But if you look at the final outcome,
Right.
24, 48 hours later, that situation completely changed.
Yeah.
So that means in human body, we are able to, we are the machine that is able to sense whatever is negative, and we convert it into a positive outcome. We have that mechanism. And I'm going to brief you what that mechanism are.
Okay.
Okay. So, so the cell in our body, we are aging and dying all the time, right? So it's sort of like if you look at the cell age in your body, you know how many cells in human body?
1 trillion?
It's more than that.
More? Okay.
So it's astronomical scale, right? So when the cell get aged and dying, right? You think it's not good for your body. It's not.
But
Sometimes
doesn't that make room for a new cell to grow or take its place?
Right. It's really hard to say. Let me just simplify the theory for you. Okay. If you want to see, okay, let's say you have two countries. Okay, two countries. They are working. The country is economic system, right? So you have the young population, you have the old population, you have middle age. You know what kind of population give you the highest power? Well, it's young to middle age. Okay, the young population sometimes is not yet functional because it needs to mature, right? So it's actually between young and middle age that give you the highest strength. And the reason is because if you are in cooperative society, then you have a very good communication and you have specialized function, right? And you have a big enough population. You specialize and they collaborate. Then economic system is very good because you do something I cannot do. I do something you cannot do. And we collaborate. Everybody's life is going to be very easy. Right? And
It's like this organization. We're collaborating.
Right. And also in the country, the people are dying and regenerating, right? You have young baby, you have the people, they are dying, right? So if you look at the age population curve is normally distributed. If you are skewed on younger and skewed on older, it's all not very good. Right. It needs to be most people in the middle age. That is the best. You know what happened after exercise?
A lot of old cells or damaged cells.
Yeah, would die.
Right.
And then we shift the curve on the left.
The body just naturally, the mechanism in our body naturally will get rid of them and shift it back to the young population again.
Right.
Okay.
Right. So that is, so you have the tool that is able to kill. Right? And that is selective because the young and middle-aged cell, when you have the challenge, they survive. Right? So the senescent cell, they are unable to sustain the challenge. Right? And those cells that have the challenge, that start to get aged. right? And that would attract, they will have the sun signal that release from those cells. And the immune system come in and then would clear everybody that cannot survive. And therefore, you have the population shift to younger direction.
When you say clear, just like basic, like, is it autophagy or like some cell will just grab it and eat it? Inflammation. Okay.
Yeah, we call phagocytosis.
Phagocytosis, there we go.
Yeah. Okay. So from here, you understand that the immune system from bone marrow is responsible for senescent cell clearance. And you have 2 steps to do it. The first step is you have enough immune system, enough immune cell and the bone marrow stem cell that is produced in your body. You need to have this, right? And you also need to direct those cells into the tissues you want to make it younger. How do you direct the blood? And immune cell and the bone marrow stem cell is carried by blood, right?
Right.
How do you direct this blood into the places that you want to make it younger?
Exercise.
Exactly. The best way is exercise. So let's say if you want to make your left arm younger, then you exercise your left arm, right? Then the blood get into that area. If you, is anyone play tennis here?
In fact, we do. We have a professional tennis player.
Okay. If you compare, if you are professional tennis player, and if you look at the size of both limb, which one get bigger? Exactly, right? And the reason is because if you are periodically pulling your blood to your dominant arm, then the blood get into that area and clear senescent cell and regenerate the system. Then that system becoming younger. So you have the younger arm and you have a relatively older arm. Which one are able to extract the resource, the nutrient, oxygen, all that kind of things?
The younger arm, correct?
The only younger arm. And that is the basis that if you really want to have the hypertrophy of your muscle, then very simple, pull your blood into that area. And the only way to do it is causing damage in that area.
But 48 hours later, there's no longer damage, right? And that goes back to what you said. Cellular markers by themselves are just a snapshot in time. They're not predictive of how span longevity. Okay.
Right. So you have the yin and the yang. Yin period is very short. And then when you have challenge, you get into
Is this a theory, or is it already established that the immune system is responsible for senescent cell clearance?
Yes, it's well established,
Okay.
in 1979.
Oh, okay, well.
It's already demonstrated.
Okay.
Yeah. Unfortunately, that is not in the textbook.
Okay, interesting.
Right. Okay, so you understand that we have the healing power. Everybody here, we all have that healing power. And then that is carried by blood. Okay? And the first step is you want to bring those resources into the tissues that you want to have. You want to keep them young, right? The second is if those cells get into that area, you want to activate that.
How do you activate it?
Right. I would say if you pour the blood into the skeletal muscle, you have the immune cell and you have the bone marrow stem cell. Immune cell would clear the senescent cell, and the bone marrow stem cell would sit in like the seed. You sit in there and then start to proliferate to make the population younger.
Wow.
Right? So you need to have 2 things. One is to clear. Cause, and then you measure all molecular marker is all going worse, right? But later, you see the stem cell sitting there, and then start to proliferate, and then you start to see the good things is going on. So that's why if you look at the molecular marker, you cannot explain. You see bad marker, right? And then you cannot explain, right? And the second thing is you want to activate it. If you pour the blood into the muscle, it's not 100% being activated. It's not. We found that even for the young people, it cannot, right? And the Senactiv would activate those.
How would the Senactiv activate the blood in the muscle tissue?
How do you?
How would Senactiv activate that?
I don't know. It's unknown. The only thing I know is it activates the immune system.
Activated muscle.
Yeah, because we measure how much immune cell get into the muscle after exercise with the Senactiv. Without Senactiv.
And this one we're talking about immune system regenerative, not immune system I'm sick.
Say that again?
When we say it activates the immune system to regenerate cells.
The immune system is mainly function to recognize the senescent cell and eliminate those.
Yes.
And it's the bone marrow stem cell. They are responsible for repopulating the tissues into younger average age.
Yes.
Yeah.
So, do you have a working theory of how Senactiv works and why there's more stem cell recruitment?
Yeah. So I'm later because we have the interview. I see your question, right?
Okay.
But I can give you the answer right now. You have two products. One is rhodiola, cordyceps, right? Cordyceps. We also done research in cordyceps, and we just published last year, 2024.
Cordyceps sinensis?
Yes. So we give the cordyceps and then 1 hour before, and then we look at the stem cell localization into the muscle. It actually, if you exercise, then the stem cell would home into the area. But if you have the cordyceps, then you can advance the time. And for RG1, it's different function. For RG1, because exercise is able to mobilize the immune cell and bone marrow stem cell to the challenged tissues. And the RG1 is able to activate those. And you see the senescent cell is going down faster.
Whoa.
Okay.
Got a healing agent.
So now you know the action of the Senactiv.
Which ties back into the recovery.
Yes. Yeah. So let's say under normal condition, you just exercise. Let's say 70% of the immune cell you recruited into the muscle, they are functional. You can probably make it 100% functional. To recognize senescent cell and kill them effectively by Senactiv.
Whoa. All right.
Okay. You know, one of the reasons that people get fatigued is because you have the senescent cell population in the tissues. You feel fatigue.
So it's also lactic acid buildup, right? Is that contributing to fatigue?
That's not true.
That's not true?
Lactic acid, 30 years ago, we think the fatigue is because of the lactic acid.
Right.
And now this has been
It's been proven?
removed.
Wow, okay.
It's not the correct knowledge.
So the working theory now for fatigue is actually senescent cells in your muscle tissue?
Exactly.
mean-
Actually, for the entire body,
Fatigue from exercise or fatigue in general?
in general.
Oh, wow.
Yes, in general. Fatigue is happening here, right, in the brain,
Wow.
right?
Whoa, this is huge. So lactic acid is no longer the main primary function why you feel sore and fatigue?
No.
Whoa, okay. We'll have to...
Is that why sometimes you might feel tired before going to the gym and you all of a sudden feel way better after working out?
Right. Actually, when you challenge your tissues, you start to have the phagocytosis. So that is the immune cell get into the tissues, clear senescent cell, right? And you do not feel fatigue that time. And then you start to have the bone marrow stem cell with seeding only to the places that has the phagocytosis, and then repopulating into the normal total cell number. And at that period, you need to reconnect with the nerve, right? Because the new cell needs to connect with the government. Right? We govern the new cell, right? It needs to connect, right? And that, when the cell searching for nerve, and that is the time you start feeling pain and fatigue.
Okay.
Right? But if you can speed up that process, then the resolution of the fatigue is faster.
That's
right. And one of the simple way to do it is acceleration of the phagocytosis by Senactiv.
Because it's recruiting more.
Well, recruit by exercise.
By exercise, yeah.
You activate when they are in place.
Okay, this is, man, we got some homework to do. Like, whoa.
Right. Okay, next. Okay, what causes cell aging is also important for you to know, and that get into the knowledge why we cannot live forever. Okay, you all know that in mentality of human, we all look for prosperity. Prosperity means what? Expansion in the resource for survival, right?
Mm-hmm.
Right. Money, material, territory, right? And let's just give you one example. If you look at the nation that are expanding, what will happen? Just look at the sociological perspective.
Eventually breaks down.
Exactly. You will eventually break down. That is very simple physical law, right?
You can't expand forever, right?
You can't expand forever. Otherwise, you will have to remodel your system to suppress the entropy. Right? The single cell is the system that suppresses the entropy. Right? In multicellular system, the cell can collaborate, right? Like the human society. And that is the reason we can further suppress the entropy and expand further. So humans are bigger than rats.
Right.
Because we remodel the system to suppress the entropy. Right? But for human beings, like as we evolve, we cannot mutate. We cannot remodel. Right? So the only way to do it, to make ourselves to survive forever, is to maintain your size. You don't want to expand. Let's say you have 10 trillions of cells. Today, if you have one more cell grow, you need to be very careful because they're expanding your size. And the metabolic system designed in human body can only suppress like 10 trillion cells. So if you want to grow your body weight 10% more, thermodynamically, it's not favorable. Right? So that mentality is very important for you to keep. So if you have the tool that can kill the cell, can target your senescent cell, you kill them, and you can regenerate the cell at the same amount of the cell. Okay, you kill, let's say you kill 1 trillion cell and regenerate 1 trillion of the cell.
Right.
To maintain the optimal size, then you can survive forever. And the reason we are not seeing anybody like that is because we are favor expansion. growth, right?
Right.
You see, all government, they look for whether the system is good. It's looking for the GDP growth, right?
Yeah.
That's human mentality, right? and we also needs to be very careful. We look for bigger muscle mass. Is that good?
Right.
Then if you have the idea, then you need to know. We need to very, very careful on that.
Very careful. Right?
Okay. And also we are facing external challenge. We have the infection, we have a radiation, we have all sort of tracer that also make us older. If they are persistent, if they are only one time, if they are periodic, then it's good. Because that challenge is going to recruit the immune cell and the bone marrow stem cell to the places that faces challenge. Kill the senescent cell, and then you remodel the tissues, and then next time you face the same challenge, you are robust.
So are you saying repeated radiation exposure is actually good for you?
Periodic. If you are persistent, right? If you are right, that's exactly.
Would that be like kind of like getting 10 minutes of sun every day that you get that exposure?
Right. If you have persistent challenge,
Jesus, snuck that in.
then it's no good.
Persistent. Yeah.
You don't want to have a persistent challenge. You want to have a periodic.
But putting your face in front of the microwave for 30 seconds is fine because it's occasional radiation.
Make sure to do that every day.
Yeah, actually,
30 seconds.
there is an early experiment that published in Russia that if you have a low, high dose radiation, it's going to kill you, quickly, make you age quickly. But if you have a low dose radiation, the lifespan is longer,
Wow.
Interesting.
right? Okay. Yeah. So keep in mind that you don't want to change your body weight if you are age 25. Okay. And then if you are age like 65, they mostly have higher body weight compared when they are age 25.
Right. So the key is to, as you get older, reduce your weight to make your system smaller.
Or maybe figure out your ideal body weight and try to stay as closely to that as possible.
Exactly. And then periodically challenge.
Periodic. Okay.
Okay. Next. Okay. This is the evidence showing you that excessive cell growth would cause senescence. So if let's say you put a cell into a culture media, you start see the cell are growing bigger and bigger and bigger, and they are start to functional, right? When they are small, they are not functional, right? But you want them to grow bigger. But unfortunately, if you are keep doing that, then you can see you get into the situation that the total cell body is too big to be sustained by the nucleus. The nucleus is like the soul of the cell body. Okay, if you have the nucleus cannot grow.
Right.
The cell are able to grow because the cell enjoy they have the nucleus, and then they expand. So when cell growing bigger, then the cell becoming unhealthy.
Mm-hmm.
The unhealthy cell is going to release the mediator that tells the environment I'm getting old. And then the immune cell would be attracted to that area and kill the unhealthy cell, right? And the Senactiv is accelerating this process.
When the cell's getting old, does it contaminate other cells around them? But when it releases that mediator?
Yes, exactly.
Okay.
Yes.
So it's like a vicious cycle. If you have a lot of age cells, make the other cells around them
Yeah.
age faster as
The
well.
faster you age, yeah.
Right. And also not only that, let's say if you have a senescent cell and you have a big body, right? So let's say normal people has 10 trillion of cell, and I have 11 trillion of cell, right? And let's say we have 10% of the cell population of senescent cell.
There's more senescent cells in the 11 trillion.
11 trillion,
Yeah.
right? And that would consume more bone marrow stem cell and immune cell, right? So if the bone marrow stem cell and immune cell go into that area, then the rest part of the body
Yeah.
is going to senescent, keep older, right?
Right.
So that gives you the idea that the total cell number in your body is also very important. So you need to prepare the scale, the weight scale for yourself every day and make sure your body
Yes,
weight
yeah.
is stable.
We're doing weigh-ins every day so we can live longer, guys.
And then challenge, right? When you challenge your body becoming younger,
Yeah.
right? And the younger body and the older body, which one are able to attract the nutrient more? Which one?
Younger one.
The other one.
Younger body.
Yeah.
So when you are younger body, you need to be very careful on your diet. Right? Okay, next. So this is single cell. And this is the mechanism that has been published in 1979. It tells us that our body has the inherent mechanism to recognize the senescent cell and kill them. Okay, the experiment very simple. You take out the blood, and then you know that the red blood cell. What is the longevity of red blood cell? It's a little bit longer than that. It's 3 months.
3 months. Okay.
Right, 3 months. So red blood cell 3 months. So you take out the blood and then you sort of you use the centrifuge to sort of separate the young and the old red blood cell. The young red blood cell is small and old red blood cell is big,
Okay.
right? Because expansion,
expansion.
is getting age, right? So you can sort of using the cell size to separate. And then, okay, so I have a 2 tube. One tube is young red blood cell, and one tube is old red blood cell, right? And then I start to get the immune cell, put the same amount into the young population and into the old population. And you start to see that the population in both test tube, the red blood cell population started going down because the immune cell will start to kill,
Oh, the senescent.
blood
Yeah.
cell. right? And which one has faster population decline?
I think the older one.
Older one. That is the result, right? So for younger cell, you have a population decline 5% per hour. For the old population, you have a 35% going down per hour. 7 times difference. Okay, and Senactiv accelerate this process.
Do we know the cell clearance per hour with Senactiv?
No, but we are doing that
Okay.
in Brennan's Harris lab.
Oh, wow. Cool.
Okay, this is the bone, right? And this is the places where you produce bone marrow stem cell and the immune cell.
That's
The
nuts.
upper side is the immune cell. You have a whole range of the weapon
Yes.
to kill the unhealthy cell,
Osteoclast, yeah.
right? And you have all sort of tissue stem cell.
Yeah.
They all coming from the bone. So the bone is the most important organ in your body for cell turnover. Kill the senescent cell population and regrows into the young population.
Wow.
bone, very important.
And as someone ages, obviously their bone health is not as strong as when they were younger. So on top of the aging cells and senescent cells, it's harder to maintain young.
I think your idea is brilliant idea. Let me just show you the evidence. Next one. Okay. If you look at on the right side, that is the bone percent mass, right? So these are the animal that is also sponsored by NuLiv Science.
Yeah.
Is this was this the longitudinal rat study we did?
Yes.
Where you did?
Yeah. If you treat animal very well, you give very good temperature and food, water, all accessible to the animal, and they are genetically identical. Then the question is how long they can survive. The longest one is 3 years, and the average age is 24 months, 2 years.
Whoa, a whole year more?
So they are genetically identical, or similar.
Yeah.
Why some animal die early and some animal die late?
Bone. The bone health?
Right. At the beginning, we just
Not
have
too
no
well.
idea, and we measure a lot of molecular marker. And what we do is very simple. Because we have the longevity data for every single rat, and then we can classify. We divide it into 5 groups based on their longevity, their survival time.
Mm-hmm.
So you can see LS1 means lifespan 1. It's black. It's the short-lived.
Yes.
You have the blue line there is LS5, lifespan 5. That is longest lived, right? And if you look at the percent bone mass is the bone divided by normalized by the body weight in percentage.
Blue, yellow, green. So obviously the ones that lived the least was the black and red, and they had the smallest percentage of bone mass. Is that correct?
Yeah, you are very fast.
Did Senactiv have any impact, or was it recruiting too much bone marrow?
I give you that later.
Okay.
Okay. If you just look at here, one of the reason that you see
That's
the
crazy.
LS1 is the short-lived animal. When they are age 6 months, is about the age in human is like 25 to 30 years old.
Yeah.
And you found this population, they die
Early.
they start to have the die in 12 months. Then even they are young,
Yeah.
right? And they have the lowest percent bone mass to body in percentage.
And this was just observation. Nothing was done to these rats, right?
Nothing.
Wow.
They have the best life.
Yeah.
They're eating McDonald's every day.
Yeah. Okay. And if you look at the long live, which is
Holy
the
crap.
LS5, the blue line and the yellow line, right? And that is, they can sustain for more than 24 months,
Twice as long, yeah.
Yeah.
right? And genetically identical. But unfortunately, if you look at the percent bone mass, they are declining with their age.
Of time, yeah.
And if you ask the question why they decline, if you look at on the left side, if you look at their body weight,
Oh.
You see-
This goes back to your earlier comment about too much cellular growth or mass requires more
right?
recruitment from your bone marrow, which then,
You can be the best sales
so yeah.
or marketing.
So you want to maintain, okay. So there was definitely a correlation between body mass and early death.
Yes.
Okay.
And that reason is because if you are big, you consume more bone marrow
Right.
resources.
That's why there's no such thing as a really big 80-year-old. Like,
You don't want to promote muscle growth forever. That is, it's not a wise thing to do.
interesting.
So you need to optimize the muscle size as well.
And also, taller people tend to live less long than shorter people.
That's also
So-
true.
Exactly.
More bone, more utilization of bone mass, or lower bone mass.
Yes, you are very smart.
That's true.
Keep small.
There's no 6'10", 80-year-old either.
Yeah, makes sense.
And
It's just more resources that your body has to come up with or use up.
Yeah.
right. And for the next life, you want to be woman.
Warm.
Woman.
Yeah.
If you look at, if
Yeah.
you just look at,
The female, right?
you see the male and female ratio.
Yes.
You found that the short-lived, the black line, mostly male,
Yes.
right? If you look at the
Ah.
long-lived group,
It's only 1 male in there.
Wow.
It's gonna be me.
right? Yeah, the blue line and yellow line, mostly female,
Wow.
right? And you know the reason why female are living longer? Because their body weight,
It's
Small.
oh.
you know why their body weight not grow as fast as men. If you look at before the first the first menstruation,
Yes.
you see the boy and girl, they grow almost at the same rate in body weight. But when women start to have the menopause, the menstruation, you start to see their body weight is growing, but not as fast.
Mm-hmm.
Interesting.
So that gives us a very important lesson. Losing cell sometimes is not the bad things for human.
Very interesting.
Pain, you're losing cell into regrow, right? You bring pain, right? It's like an exercise. Exercise, you have pain.
Yeah. And on the reverse, a male at that puberty age will grow way faster.
Exactly. Yes.
Were all rat groups on the same diet, or was it unlimited food?
Unlimited.
Yeah, it
So the
seems
ones
like,
that gorged and ate too much and gained more weight
Yeah.
died earlier, essentially. Yeah.
Yes. Okay,
Interesting.
next. Okay, if you just look at male alone, right? Male and female are obviously different metabolic system because in men we do not have menstruation, right? But if you look at the male rats, okay, if you look at the body weight, so we divide the animal into 4 different groups according to their longevity. Okay, the Q1 is the short-lived. Q2, Q3, and Q4 are longer-lived. So you just compare Q2, Q3, and Q4, right? Which one live longest? Q4, right?
Q4, almost.
And what is the difference between
Almost 2
Q4
years.
and Q2?
Yeah, because they had lower body mass from 100 days all the way up to death. Yeah.
You found that the Q2, Q3, Q4, they will eventually reach the maximum weight they can sustain.
Oh. Yeah. But Q4 reached it toward the late.
Exactly. Yes. When they reach their maximum weight, what happened?
Did that
Start to die off.
Start to die?
Yeah.
Yeah, the body weight starts to drop,
Or drop?
right? You have a higher senescent cell population. You have an older population more than younger population. The younger population is still growing. The older population is going to decline.
And their bone density is dropping too.
Right,
Right. Each friend.
right.
Wow.
So that means if you just don't control your body weight, you will eventually grow into, the human is the same. Let's go to next. This is human. So if you ask the question, when is the time in human that you have the highest body weight? If you just look at the short-lived population and the long-lived population, you see the short-lived population reach the peak weight at about
Just before 60, late 50s?
Yeah, just before 60, right? And that is 80 kilogram in average, right? And when you reach that peak weight, the body weight starts to drop, right? So the human life is 2 periods. One is the cell growth rate greater than cell death rate,
Yes.
and that the body weight is increasing. And then when you reach the peak weight, you start to have the cell death rate higher than the cell proliferation rate.
What's scary is I know, at least for the men here, we're all probably higher than 80 kilograms, right? So we're in the short-lived group.
Right. For the long-lived group, it also has the same curve. And that gives us a very important lesson. That although you are a long-lived group, you're still reaching the peak weight.
Yeah.
And when you reach the peak weight, no good, right? So if you look at, I talk about the life has 2 periods. The first period is very long. It's from age 0 to age 4. Let's say you are long-lived. Age 0 to age 70. You have 70 years expansion period. And then you have only like 20 years depopulating period. The cell death rate is higher than cell proliferation rate.
But at least that the stage 2 is more prolonged versus the short-lived. The decline is much rapid, and it seems like then they die. Like,
Yeah.
so rather,
Most of the medical research, they are putting the correlation. What marker is the predictor of longevity? And most of the research is done before age 70.
so we don't. So the literature out there is very little on past 70.
Exactly. Yeah,
Okay.
you got the point. Okay. Now we know that if you ask the question, the weight gain, is that a predictor of longevity? The answer is it depends on what period. If you talk about the first 3/4 of the period, the answer is yes.
Yeah.
Right.
But when you after age 70, then it's completely opposite answer. If you weight loss faster, die early.
Interesting. Scary.
So maintaining muscle mass in later stages of life
Exactly.
is far more important
After
to a
50.
later longevity for multiple counters, but yes.
It's very smart. Yes.
Yep.
And
Especially
also,
after
how
50.
about the first 3/4?
Mark and smart in the same sentence. Holy
How about the first 3/4? Then it's right.
No, that was a very clear observation
Yeah.
for the
Right, right,
layperson.
right.
Especially even here, it shows that if you include exercise at 50, should be able to keep going.
Right. So you have 2 different life goals here.
Yeah.
Okay? In the first 3/4 of your life, you want to suppress your weight gain, regardless this is muscle or adipose tissues. Right? But if you exercise, then the oil resource is prioritized to the muscle. The bone marrow resource is prioritized the muscle, and therefore your body looks nice. Right? You will not accumulate your adipose tissues. Right? So the first 3/4 you want to suppress. In the last quarter of your life, you want to
Actually, gain weight.
prevent weight loss.
Yeah, prevent.
You don't
weight
want to
loss,
gain weight.
but prevent weight loss.
Prevent weight loss. If you are age 65, gain weight and weight loss all increase mortality.
Oh wow.
So maintain body weight is extremely important lesson for everybody. So sometimes you need to have two tools.
Yeah.
The first tool is get rid of the cell. The second tool is increase the number of the new cell.
Yeah.
So you need to have two tools in your kits. And exercise will kill, right? And RG1,
It will build.
yeah,
Yeah. So exercise is the one part of it.
right.
Yeah.
And
then
Senactiv is the second part.
It's the more
The nutrient, protein is promoting growth because when you have the new cell repopulating, you need to have the nitrogen source. You need to nitrogen. Carbohydrate and fat has no nitrogen.
You said nitrogen?
Yeah, nitrogen.
Oh, wow.
protein.
Because
Yeah.
DNA is made by nitrogen,
Yeah.
right? You need to repopulating the cell. You need to have the DNA. And DNA need the raw material, which is nitrogen.
So someone like RFK Jr. that has a lot of muscle mass as an older person is
That's
a good,
good.
thing.
Yeah.
If they can maintain. Well, I think this is important question. It depending on whether they are able to maintain, right?
So if he's able to maintain his weight for the longest period of time, so as an older age, you kind of want to gain muscle to see, because after older age, I guess muscle degeneration just starts hitting in. So as the longer you're able to maintain muscle is a good thing at an older age.
Maintain muscle. You can get muscle, but at the same time, you want to reduce your adipose size. You want to keep the body weight static.
Okay.
Yeah. So the body weight is the most important things. Okay. And then second, we talk about muscle ratio. Okay, next. Okay, so we want to promote exercise because exercise will mobilize the bone marrow stem cell into the muscle. And this is there are two types of exercise. One is aerobic and one is resistant exercise. Which one causing more damage?
You would
Muscle.
think resistance.
Yes, resistant exercise causing more muscle damage. Okay, if you look at this is CD34 cell is bone marrow stem cell.
Yes.
Okay. In aerobic exercise, if you have two lines there, one is high intensity and one is low intensity. Only high intensity mobilized the bone marrow stem cell into the blood. So you want to right sprint. Yes, that's a
What
good
was the
idea.
definition of high intensity?
You feel
Okay, it was just
fatiguing
perception.
exercise.
Okay.
Yeah, you
So
put
was
more
it-
effort,
okay.
brain effort.
Hmm.
Okay, and then low intensity exercise, no effect.
Interesting.
So this explains the reason why the low physical activity, although it's low entropy, is not helping for longevity. It doesn't make you live longer, right? Because you want, this is giving you the idea that the exercise can mobilize the healing
Yeah.
source into the blood, and then it will eventually deliver into
The muscles.
wherever you have challenge. And on the right side is resistant exercise. If you have a higher intensity, which the gray line is the higher intensity,
80%.
the gray line, you see,
Yeah.
you damage your muscle more, you recruit more bone marrow stem cell into the blood.
Yeah.
Next.
That CD34, is that the only biomarker for the bone marrow?
CD34 is the widely used.
Okay.
If you want to do the if you want to in medical society, if you want to isolate the bone marrow stem cell, this is the marker they use.
Okay.
Can I have a state a question? You said nitrogen replenishes the loss you're taking throughout your life, right? High nitrogen foods, is that correct? So nitrogen dense foods, for that matter.
Nitrogen dense food, you mean the protein, right?
Protein.
Protein is the nitrogen.
And so I looked up in the midst of our conversation nitrogen-dense foods, and one of the highest ones was beetroot, is a high nitrogen-dense root. So in combination, Senactiv and beetroot would be theoretically.
A new question.
Wow, there's a brand out there. Human,
Yeah,
if you're
yeah,
looking at this, Senactiv.
Yeah, that's the new question. Yeah, I do not believe people has looked at this.
Looked at it. Okay, interesting.
Yeah, you have the beetroot and you have Senactiv. If you combine together, what happened? And that is the open question. It has not been answered yet. Good. So you can have a very good scientific team here to develop the product.
We're all your assistants.
Right. Okay, this is the muscle we have done. You see the RG1 and the placebo, they are about the same.
Yeah.
There's no additional benefit, right? If you recruit the muscle, if you challenge the muscle, the bone marrow stem cell is going to seed into the muscle 24 hours later. The pulse is 24 hours later.
It seems like the placebo had higher recruitment, though.
No, it's
No?
not. It's not different. It's the same.
It's the same? Okay.
Right. Okay, next. Next. But if you exercise in moderate to high intensity,
Okay.
then if you look at the senescent cell marker, you see the lower part on the left. That is aerobic exercise. You see aerobic first.
Yeah.
You see the medium to high intensity doesn't kill the senescent cell in the muscle if you just do cycling. But if you have Senactiv, it will kill the senescent cell.
Even with moderate exercise.
Yeah.
Exactly.
Wow.
And if you measure the immune cell inside the muscle and the CD34 muscle inside the cell, it's the same, right? But it activates the
Yeah.
function.
We
So the Senactiv doesn't help
It
for
optimizes
the
it.
recruitment of the CD34 cell
Yeah.
into the muscle. It doesn't help, but it helps to activate.
the earlier slide showed there was not much. There was no significant difference in terms of recruitment of bone marrow, but the Senactiv turns that bone marrow into activating to.
Fully functional.
Okay. Wow. Okay.
Okay, if you look at the right side, resistant exercise is consistent. You see the senescent cell marker. That time we tried another marker for senescent cell. Senescent cell has multiple marker. So in order to confirm, we used different marker. The RG1 also lowers the senescent cell after resistant exercise by about 30% more. Resistant exercise alone will kill the senescent cell. But if you have the RG1, it kills more.
And was this just any resistance exercise? Was it 60% perceived exertion, 80% perceived exertion?
Yeah, this is high intensity.
High intensity. Okay. This is Jared level. Wait.
Right. Okay, next. Okay, next. Okay, this is the final slide. Okay.
Been very patient.
Apology for the long.
Shit.
But this is the most important one.
Amazing.
Okay, so you want to position the Senactiv as a senolytic sports supplement, and there's no alternative in the current market in the world.
Pull blood, activate, reset.
Okay, this is the only one in the market. Okay, why sports supplement? Because you need to have an exercise
You're
to
activated.
pull
Yeah.
the blood into the muscle, in the brain, and the skin.
That's how we've been marketing Senactiv.
One thing we like to say is that the sport could be different at different age levels. an older person just walking could be their sport.
Or pickleball.
Well, that's not.
Walking's not.
Well,
high
if you look at the
Yeah, not high
evidence,
intensity.
if you look at the evidence, the first things I show you,
Yes.
that is belong to the moderate
Yes.
exercise intensity.
Moderate. Okay.
The high intensity make you live longer. So
Yes.
you want to promote resistant exercise for older people,
Resistance.
Like RFK Jr.
right? That is the best for older people.
What about for younger people? Do you also?
You still want that resistance exercise, right?
Younger people should focus on not to allow their body weight increase, even muscle,
Even muscle.
right?
You don't want to get too big.
You have to find your
The
ideal size.
adipose tissues needs to be kept very low. Okay, so you have two things. You need to exercise. You have the Senactiv RG1 that activate immune system inside the muscle tissues. And you have these two tools, you can reset the age in skeletal muscle. Right? And then you have periodically reset your cell age in the
Yeah.
muscle and then maintain your static weight and muscle mass. Supposedly you can survive forever. You keep young forever.
Let's do it, guys. Forever young.
Supposedly.
It's
And
cool.
we also found that I have to be honest that the Senactiv, although we studied for in the past 20, 25 years, we still know very little about that. And this is the current knowledge we have. And you cannot find it elsewhere in the world.
Right.
Okay? And it would decrease the fatigue feeling as well.
Because you have lower senescent cells in your body.
Likely, yes. And it would improve high intensity exercise performance.
We had some customers tell us that just taking Senactiv, they felt euphoric.
Yes. If they are doing exercise.
Yeah.
I think the result is very reproducible. Yeah, we at the beginning I'm skeptical, right? So I give the student and another faculty member and another student, and we will repeat and to see the performance data. And then we come to the conclusion that it will lower the fatigue feeling when you do weightlifting.
Interesting.
Yeah, the fatigue scale is going down by 2.
Wow.
That's quite significant. Okay, this concludes my presentation today.
Thank you,
I hope
Dr.
it's helpful for everybody.
Fantastic.
Thank you, guys.
It's
Thank
amazing.
Should we take a small break before we do
Yeah,
the
sure,
interview?
sure. It's long
Oh,
time.
Q&A.
Sorry.
We got any Q&A?
Your first slips
I
away.
guess I have a question. I have one.
See, trying to think of the best way to phrase this. If it's true that when you do resistance training, it builds bone mass, and when you build bone mass, you also having more muscle causes you to build more. You could lift heavier and get more bone mass eventually. Wouldn't you want to be stronger and have more muscle to get that bigger bone mass that will help you live longer, essentially?
Well, the answer is it's partially true that the exercise would increase the bone mass. We have done experiment before, and we found that some other lab has the similar result than us. If you just do weight training, what happened is the bone mass only increase in the bone and the muscle area that has the highest inflammation, the highest damage. But if you look at the entire body bone mineral density, it's actually slightly reducing.
Yeah, density versus mass.
So that gives us the very important idea. You know, bone is the tissues that sustain the gravity. It has persistent gravity challenge all the time. So the bone is the number one place to enjoy the bone marrow stem cell and immune cell, right? So if you challenge the bone get information. If you have a more challenge, the bone get information. And then the bone marrow stem cell home into that area and proliferate more. But the problem is you have the entire body to be taken care of by the bone marrow stem cell. Okay? So if you are a baseball player, you never do upper body weight training, and then all of a sudden you start to do body weight training upper body, right? And then you get bone marrow stem cell homing to the upper body.
Yeah.
Then the body, you can see the bone marrow density increase in the upper body. But if you look at your leg, it's slightly reducing.
Wow.
So there's
Homeostasis.
redistribution of the bone marrow stem cell.
What if you train
everything, including
If you
your
want
neck?
to train everything,
Would your overall bone mineral density
Right.
go up in the whole body?
or
Still lose out in some
that is-
areas.
that is very important question. If you train the entire body, if you challenge the entire body, then
Well, I think you're only looking at one aspect because you have to look at bone marrow, then muscle tissue on it, and then adipose tissue. So there's a balance. So you might be getting more bone density, but now you have less adipose, more muscle.
you need to have, if you train the entire body, then you need to have a very good nutrient. Yeah, you need to provide a lot of nitrogen source. If you have a more nitrogen source, then you train the entire body, you have muscle soreness everywhere, right?
Mm-hmm.
Then if you have the nitrogen source, protein, it will shorten the inflammation time. So if you don't have that, then probably inflammation for 6 hours. If you have protein, probably 2 hours,
Wow.
right? But if you are continuously taking protein, you know what happened? Yeah, you get
Too much burden on your kidneys or something?
you get proliferation rate higher than the cell death rate. Then your body weight start to build up. And for long term, it's thermodynamically unfavorable. You need to, you have a higher body weight. So that is the problem about a lot of bodybuilder. The bodybuilder, they try to build muscle, but they forgot that if you are building body weight, it's no good for health in the long term.
It's
For the
important
organs, yeah.
to just perform some kind of moderate amount of resistance training, but not too much to the point where you're exceeding your ideal body weight, essentially. Or don't do any resistance training when you're younger and wait for like when you're older, like RFK.
Right.
What's the best approach?
Best approach. Okay. My recommendation is very simple. If you are aged before 40, you want to emphasize aerobic exercise. Aerobic exercise can also keep your muscle
Sharp.
right, yeah. But the reason, you know, for entire body, where is the places that consume most of the immune cell and bone marrow stem cell? Do you know?
I think
It's
the,
actually
the gut.
pulmonary system.
Oh, wow.
That experiment has been done. If you just inject the bone marrow stem cell or immune cell into the blood, then you see most of this cell will hover in your pulmonary system,
Wow.
your lungs. So that means the rest part of the body can have only 40% to renew their system. So we renew our lung. We're using most of amount of bone marrow stem cell. So that means if you do aerobic exercise, then not only muscle get challenged, lung get challenged, and the lung get a lot of bone marrow stem cell. And if the resource of the bone marrow stem cell is all getting to the muscle, not to the lung, the muscle grow more. But if you have sun get into your lung, then the muscle growth is not as that fast. So that's why resistant exercise has more muscle gain. Aerobic exercise has little muscle gain, but the body weight
Right.
is keeping low. Okay, you know where is the most important place for storage of stem cell for the entire body?
Spine.
Is adipose tissues and liver. So when you see you have adipose tissues that is heavier, or you have a big liver, that is the representative that you have overproduction of your bone marrow stem cell.
Whoa.
And that is mostly because of the nutrition is too much. So you want to keep the body weight low as possible by aerobic exercise and using your lung to consume the bone marrow stem cell.
So we obviously know the importance of aerobic exercise, and we have studies suggesting an increasing VO2 max through Senactiv. What is Senactiv's effect through high intensity aerobic exercise and the utilization of oxygen in the body?
The only answer I know is that the Senactiv doesn't really increase your VO2 max. No, it's not. But increase your high intensity performance.
Mainly through the clearance of senescent cells, that is correct.
That is the most likely reason. Right? It warms up the immune system.
Yeah.
The Senactiv is warming up the immune system. So it allows the clearance of the senescent cell. Right? Yeah, that is the only thing I know.
Any more questions? The ladies in the back.
For Mark's question, I remember you before you had a system you were trying to coin for the Senactiv being able to cool the membrane when exercising, the muscle membrane.
You mean the cell membrane?
Yes.
I'm not sure about that, but in general, the function of steroid. You know the steroid. Do you know the structure of the cell membrane? What is the most important composition of the cell membrane? It's fatty acid, right? The fatty acid is like the train, like this, moving around on the cell membrane.
Okay.
Right. If the cell membrane has the homogeneous composition, the fatty acid on the cell membrane, if they have the homogeneous chemical structure, the dangers of that is if you have the temperature shift, the same chemical composition will aggregate together. It will crystallize. And then the membrane becoming the same species get together, and you have the membrane like this. If the fatty acid aggregate together like this big, and you have a different fatty acid, different lengths of fatty acid aggregate together, if the temperature is going down, then you start to have the gap on the plasma membrane. So one is this thick, one is this thick. Then you have the gap here. Then it's very easy to get infected. And so that's why we need to have a steroid in our diet. And the steroid would incorporate in that area, sort of disrupt the homogeneity of the cell membrane. And therefore, you have a temperature shift. You do not get gap. Right? It's more like, water has a freezing temperature at
Yes.
Yeah.
0 degree, right? But if you put something there, any salt, then you make the heterogeneity, and then you need to, at 0 degree, you do not get crystallized.
I see what you mean.
It's very similar principle,
I see what you mean.
right? So that is one possibility.
Okay.
All right. Thank you guys so much thank you, Dr. Kuo, for this seminar. I think everyone here learned a lot. We're like, whoa, okay, this is, personally for me, just learning about lactic acid is no longer the primary contribution of fatigue. That's huge. So we thank you all for your time.